Good afternoon. This is Robert.
This is Vanna.
I'm Peter Johnson.
Okay, and we are doing Lab 2 on infrared nuclear, on NMR, exercise for molecular spectroscopic structure determination.
So we're basically just going to go through how we solved the last problem.
Okay. And pretty much, it was numbered. The question is question 9, and it asks, and the problem was C2H4Cl2, and asks for the degrees of saturation. And the formula for how to get the degree of saturation is 2C plus 2 minus H, which stands for hydrogen, plus halogen minus a nitrogen over 2. So as you see, we have two carbons, so that'll be 2 times 2 plus 2, subtract that, and with hydrogen we have a 4, so we put that 4 plus 2. And then the chlorine's a hydrogen, so put 2. We don't have no nitrogen, so that ended up being 6 minus 6, which is 0 over 2. And that gives you 0, so that comes down to 0 degrees of unsaturation. And then, to get the molecular weight, the tallest one, we know that it's a base peak. And then we come on down here, the shortest one, and that gives us our molecular ion, which is 98. And that gives you the molecular weight.
All right, and I'm going to talk about the IR graph here. We're going to look at this peak right here, this first one. We're going to ignore everything here. We're looking at this peak. And what this tells us is that it's a CH bond. And since there's only one, we know that 2 carbons are symmetric. And that's basically what you get from this one peak. And I'm going to pass it to Peter.
Thank you very much. Okay. Distinct IR peaks. Is that what she just did? The NMR data. So we look at the NMR peak, and it gives us one peak between 3 and 4. That tells us that it's a chlorine bond, and there's only one peak, so they're symmetrical. So whenever you make the structure, which is the next question, you take your Cl, your 2 carbons, you go side by side with a bond in between them, and then they're each going to have 2 hydrogens on it, so they get your 4 hydrogens, and your 2 chlorines are going to go on top of that, so you'll have a chlorine, hydrogen, hydrogen, 2 of those, so they're symmetrical, and they're bonded together, giving you one peak that has both the CH indicated on the IR scale and the chlorine indicated on the NMR scale. And that's your basic structure. And Simona walked over to the other side, but she's here. And I'm Peter.
I'm Robert.
And have a good day.
Thank you.